Ifran used the setups A and B below to measure the height of the shadows cast on the screen. He conducted the experiment in a dark room by using two metal objects of the same shape but different heights. The results were recorded and represented in the graph below. Question A. Based on the graph, where should object A and object B be placed away from the torchlight so that they have the same height of shadow cast on the screen? So if you look at the graph, you can see that the shaded part is actually object A, while the unshaded part is actually object B. To get the same height is actually here and here, right? So to answer the question, object A should actually be placed at a distance of 60 cm, while object B should be placed at the distance of 70 cm. So let's write this. Object A has to be placed, okay, just let me drag this bigger, 60 cm away, while object B has to be placed 70 cm away from the torchlight. Question B asks, what can Ifran conclude about the relationship between the distance of the object and the torchlight to the height of the shadow cast on the screen H? If you look at the graph, you will actually realize that the graph, can you see from here that it's actually going downwards? It means that the further the distance between the object and the torchlight is, the height of the shadow will actually decrease. So again, we have to put in the answer. As the distance between the object and torchlight increases, the height of the shadow decreases. Question C asks, without moving the object A and the torchlight, state another way that he can get a taller shadow of the object on the screen. So if you want a taller shadow of the object, so based on object A, you can actually see, if I put a screen here, can you see the shadow is of this height? And if I put a screen further away, I'll have a taller shadow being actually cast on the screen, which that's to say that in order to get a taller shadow, I need to move the screen further away from the object. So what I can do is here, he can move the screen further away from the object. Okay. Finally, for the last question, if object A is made of iron while object B is made of frosted glass, what would be the difference between the shadows cast by both objects? Now, we have to be aware that iron is actually, okay, iron is opaque. Okay, which means that it cannot allow any light to pass through at all. While frosted glass is actually translucent, which means that it allows some light to pass through. As such, the shadow that is cast by object B, which is made of frosted glass, would tend to be a bit lighter than object A, which is made of iron. Okay, so the shadow cast by object B will be lighter as compared to object A, as object B allows some light to pass through, while object A does not allow light to pass through. Okay, the reason being, if you allow some light to pass through, the shadow will not be as dark as it should be. But if you do not even allow a single amount of light to pass through, it means that you're totally blocking out the light, and that's why you have a shadow that is really dark.